Hi there, folks. Today we're looking at perimeter and area. And so the first thing we're going to talk about is polygons. In general, polygon means many sides. So it's a closed plane figure formed by three or more segments. All right. And we've already dealt with polygons, probably of a different number of sides. And we're probably familiar with most of these names, but maybe some of them will be a little bit foreign to us. So when we look at something like this, it says classifying polygons. We know that three sides is a triangle. Four sides is a quadrilateral. You probably are familiar with like squares and rectangles, that kind of thing. But generally, four sides is a quadrilateral. Five sides is a pentagon. Six sides is a hexagon. Seven, a heptagon. Eight is an octagon. And maybe that's probably where things kind of start to putter out on you. A lot of students forget seven being the heptagon. But nine, nonagon. 10 is decagon, 11 is hendecagon, and 12 is dodecagon. And, at some point, you just have to kind of give up on naming because, honestly, the names would literally go on forever. So anything above that, we'll just call an n-gon. So if it had 24 sides, we would call it a 24-gon. All right. And so it's just a generic way to label it after we get to a certain point. All right. And so those are just quick ways to refer to things is just knowing the names. All right. So perimeter, most of us are probably familiar with the idea of perimeter is just the sum of all the lengths of a polygon sides. The area is the number of square units a polygon encloses. And then circumference is basically the same thing as perimeter, but for a circle. All right. So it's the circular perimeter. All right. And for some of our standard shapes here, we're probably familiar with some of these formulas. For a square, and I can tell that that's a square because of the sides all being the same. So a square, the perimeter is just 4 times one of the sides. The area is one of the sides squared. And really, the square and the rectangle, we could approach the same way and we'll get the same result. So for a rectangle, the perimeter is twice the base plus twice the height. You probably know it as twice the length plus twice the width. In geometry, we tend to shy away from length and width, and we typically refer to things as base and height. And honestly, it's a better way to do things, okay? Area is just base times height, or you might know it as length times width. If you continue to think of it in the old way, that is okay. All right, but again, the more you lean towards, base and height instead of length and width, those kind of measurements, it makes more sense as we move on to some of the other shapes as we get further and further into the course. Okay. Triangle, we just add up all the sides. There's not really a set formula. When you think about the perimeter of any shape, the generic format for perimeter is add all the sides together. And for a triangle, because we have so many varieties and not all the sides are necessarily the same and that kind of stuff, we just add up all the sides. It's A plus B plus C. All right. So think about the Pythagorean theorem, labeling your sides as A, B, and C. It's just add up all the sides. The area is 1/2 the base times the height. Circle, the circumference is 2 pi r, or sometimes you'll see it as pi d, because remember, d, the diameter, is 2 times the radius, so 2 pi r is the same as pi d, and then the area is pi r squared, okay? And depending on the situation, we'll leave circumference and area in terms of pi, unless we're asked to round it to the nearest decimal or something like that, okay? For example, if I look at something like this guy, we have a 16-foot by 25-foot pool, and that little symbol there, if you use that symbol, that means a foot. If you use like a quotation mark, it means an inch. So if you're not familiar with those type of measurements, that means foot. So 16-foot by 25-foot pool has a 3-foot walkway around it. How many feet of fencing would be required for a fence? So first of all, if we kind of think about this for a second, so 16 feet by 25 feet, so this is 16 and this is 25, and then we know the walkway is 3 feet, so all of these little pieces right here, that's a 3-foot, this is 3 feet, over here is 3 feet, and down here is 3 feet. And when you think about it, we want the fence to go the whole way around the outside, outside of the walkway. So we need the overall measurements for this thing. So when we look at something like this guy, we need to know what is the total distance here. And so if we look at it, The pool itself is 25 feet, but then there's 3 feet of walkway on each side, so that's actually 31 feet. Okay, and we do the same thing over here. If we look at something like this guy, again, the width of the pool, or the height of the pool here is 16 feet, but then we add that extra 3 feet on each side, so that's 22 feet when it's all said and done. Okay, and so now if I use that formula for a rectangle, the perimeter is 2 times the base plus 2 times the height, and now I just plug away. So it's 2 times the 31 plus 2 times the 22. And I just simplify. And make sure you include the units when it's all said and done. So this is 108, and again, that is feet. All right. Units are very important, especially when we're looking at a real world type of example. All right. Got to include the units. This one, find the circumference and the area. This time we'll leave it in terms of pi. It's really easy to plug it into your calculator and get a decimal approximation if we need one. All right. But again, when we talk about perimeter, we're talking about circumference this time. It means the same thing except for a circle. So that's 2 pi r. So here it's 2 pi and then r, the radius this time. If the diameter, if the whole way across is 16, it means the radius is 8. And again, we could have done the pi d, but the more acceptable format of this thing is 2 pi r, so I just went with that. Pi d will give you the same thing, but it's one more formula that you would have to know. So that's 16 pi. And again, that is in inches, so the circumference is 16 pi inches. And if we wanted that rounded off, we would just plug that into our calculator, 16 times pi. And again, use the pi button. We're beyond the point that 3.14, yeah, you could use that, but just use the pi button on your calculator. It's more accurate. It gives you a couple more decimals, okay? Area, pi r squared. Again, the radius is 8. We already did that in the previous piece of this thing for the circumference. And so once again, I'm going to leave it in terms of pi. That's 64 pi. Again, if we wanted this thing as a decimal, we just easily plug it into our calculator. But now the units are inches squared this time, all right? So again, make sure you're using the appropriate the appropriate units for these. If I look at the next one, pulling something off of the coordinate grid, it says find the perimeter of this thing. And so if we want the perimeter, we need to add up all the sides. And so for this one, I have to find the length of each side. So maybe I count this guy. It's 1, 2, 3, 4, 5, 6, 7, 8 units. So there's 8 units. This is 1, 2, 3, 4, 5, 6 units. But now from here, I don't have that third side, and I can't count it because it's diagonal. So you have to use your Pythagorean theorem to find that missing side. So we're kind of using some of these skills that we've done in other things. And this one we did in the another lesson, actually. So let's see, 8 squared plus 6 squared equals c squared. So that's 64 plus 36. If you don't remember that the answer here is 10, spoiler alert, that's what it is. And then I take the square root. Okay? So I get that last side. Now, I've done a little bit of work here, but I still haven't answered the question. That's 10 units. So now the perimeter, I add all the sides together. So the perimeter now, let me switch back to blue. It's just 8 plus 6 plus 10. So the perimeter equals 24. And there's no real units to put on this thing, so we're just going to say the perimeter is 24. Okay? It's 24 blocks or whatever you want to call it. We don't know what those measurements are. They're kind of random in terms of the actual size, but it's just 24 units. And then, of course, the area. Area equals 1/2 the base times the height. The base of this one is a 6, and the height of this one is an 8. And again, because this is a right triangle, that allows us to list the height as 8. If this wasn't a right triangle, we'd have to draw a straight up and down line to find the height of this thing. And so once again, I just plug away here. On this one, it also happens to be 24, which is surprising. Okay. And even if we want to label this generically, we could call the perimeter 24 units. The area would be 24 units squared. Okay, so just be aware of the units that are kind of associated with this. If we look at this guy, it says find the area to the nearest square yard. And see, the thing about this one is a lot of times students will look at this and it just all they see is find the area, okay? We don't quite read the whole thing. And so what we end up doing a lot of times is this. We say, okay, 5 base times height, 5 times the 2.5. And we say, okay, that's 12.5. But now think about the units you just found. That was 5 feet by 2.5 feet. So that means my area is 12.5 square feet. But that's not what the question asked for. It asked for square yards, okay? And we can either convert that 12.5 square feet to yards. It's just a matter of understanding the relationship here. So like when you think about a square foot is a square that's 1 foot by 1 foot. A square yard is a square that's 1 yard by 1 yard, okay? And so if we think about the conversion between square feet and square yards, all right, a square yard being 1 foot by 1 foot, that's like 3 feet by 3 feet. It's the same thing. So 1 square yard is actually 9 square feet. Okay, so we can use that and use factor label and say, hey, the conversion here between square feet and square yards, 9 square feet go with 1 square yard. And see, now these guys cancel out. And it gives me 1 point, hold on, 1 point something. Let me plug it into my calculator, divided by 9. 1.38, so 1.39. And that's square yards. It asked me to round to the nearest yard, so we're going to say it's 1 square yard. Okay? Now, if you didn't follow that, here's the other way that you can convert it. You can say, you know what? Square feet is like feet times feet. Okay, if you want to think about it that way. And so if we take the same approach using something like factor label, we can use the regular old conversions that we know. We know that 3 feet go to 1 yard. And so what happens is feet and feet cancel out, but now I still have feet. I have to do it again. And so I use the same factor label piece. I say, oh, 1 yard and 3 feet go together. And now watch this. Feet and feet cancel. Now all the feet have canceled out. And I have yards times yards, which is yards squared. I get the same thing. Okay? That to me is probably the quickest way to do it using one of these 2 methods. But again, some of us might not feel comfortable with that. Some of us might not understand where that's coming from. The easiest way mentally to think about this is to convert the feet to yards before we get the area. Okay? And so if you look at something like this guy, 5 feet, well, take that off to the side and convert it to yards. Say, okay, let's change 5 feet to yards. So again, there's 3 feet in a yard. So that gives us 1 2/3 yards. And so by just rewriting it that way, 1 2/3, and now I do the same thing. Let me section this off here. If I do the same thing with the other measurement, the 2.5, so 2.5 feet, again, convert it to yards. And a lot of this goes back to Algebra 1 and maybe to science class where you've probably done a lot of factor label. And so those cancel. I think this gives me 5/6 if I do everything right. And now from here, I could just redo this problem, but keep it in yards the whole time. Say, okay, the area is base times height. So for this particular example, sorry, that is a terrible looking A. I know I can do better than that. I believe in me. So the area is base times height. So the base is 1 2/3. And the height is 5/6. And again, because it asked me to round this off, I can just plug it right into my calculator. And once again, I get the 3.9 square yards. But again, it asked me to round it to the nearest yard, so it's 1 yard, or 1 square yard rather. Okay, so a couple different ways to do it. All right, you might feel most comfortable converting it right away and then finding the area, or you might have to do a little bit more thinking in terms of converting the area from one unit to the next. Okay, let's talk about the area addition postulate. All right, and we've had a couple addition postulates so far. We had the segment addition postulate. We've had the angle addition postulate. Now here's the area addition postulate. If you remember, segment addition was the little pieces add up to the whole thing. And angle addition was the little pieces add up to the whole thing. And guess what? Area addition is the little pieces add up to the whole thing. So the area of a region is the sum of the areas of its non-overlapping parts. So if I find the area of all the little parts and add them together, it gives me the area of the whole thing. Okay? And what we use this for is basically if we have a shape that's kind of strange to us. We have a shape that we don't have a formula for. So when you look at this, the shape is like a staircase. We don't have a formula for finding the area of a staircase, okay? So what we do is we break this into pieces that we do understand, okay? And so when you look at this, again, those values that are written here, the symbols that are written tell us that, all of these are 4 inches. So everything that has 1 dash is 4 inches. Well, let's start breaking this thing into pieces. If I were to kind of section off this top, well, now I've created a square that's 4 inches by 4 inches. And I can easily find the area of that, all right? I find the area of that by doing base times height. So this is 16 square inches, okay? And so then I might move on to the next section and say, okay, well, maybe I'll break this guy. And you could break this into a bunch of little squares, but hey, here's a rectangle. And you know that right here, this is 4 inches. And you know that the length of that rectangle is actually 8 inches. And we know that because of the segment addition postulate, right? See, we know this is 4 and this is 4, which means the whole way across is 8 inches. Okay, so it's segment addition kind of piled into this thing. Well, now I can do base times height for this piece and get 32 square inches. And then maybe I'll look at that last piece and say, wait a minute, I know what the dimensions of this rectangle are also because that's 4 inches. And I know that the whole way across is 12 inches. And I know that because of segment addition. All right. And as I look at this thing, yeah, this piece was 8 inches and this piece is 4 inches. So segment addition means the whole way across is 12 inches. All right. So now I can find the area of that piece. Sorry, I was doing this in green. I can't break from that tradition now, right? And so when I do this piece, the 4 times the 12 is a 48. So it's 48 square inches, okay? And so when I look at this, basically, I found the area of all these little pieces. I just have to add them up, okay? That's the area addition postulate, okay? So I add all these pieces together. It looks like it gives me a 96. So 96 square inches, okay? But I use the area of pieces that I know how to find the area of, and I say, hey, all these little pieces add up to the whole thing, okay? If I look at this guy, same kind of thing. I want to break this into pieces that I understand. And notice it says here, I see some symbol. I've got a 6-inch piece, 6 centimeter piece here. This piece is also, I think the whole way across there is the 6 centimeters. So the whole way across is 6 centimeters. And since those pieces are equal, it means that each of these pieces is 3 centimeters. And so that's an important measurement because that's kind of the radius of that top piece is kind of looks like a circle, but it's only half the circle, okay? And so if I start breaking this into pieces, let's start with this guy down here. Well, that's just a triangle. I know the triangle, the area for a triangle is 1/2 the base times the height. The base for this one is 6, and the height is 8. And I kind of have to visualize that if I kind of flipped that triangle upside down in terms of base and height, all right? So the area here is 24 square centimeters. But now that top piece is the one that's a little bit tricky. It's like a circle. I know how to find the area of a circle. That's pi r squared, right? But it's only half the circle, so I have to divide it by 2. And so I'm just thinking outside the box a little bit, using the things that I know, but applying it to a slightly different situation, okay? The radius of that circle is 3 centimeters. So that's 3 squared over 2. And this is a situation where I would get 9 divided, so I'd get 4.5 pi. But this is a situation where I don't want to leave it in terms of pi because I have to add it to 24. And if I leave it in terms of pi, I won't be able to add that 24 to it. Okay, so I'm going to plug this one into my calculator. If I hit all the buttons and do my thing here, use the pi button, I get 14.14, and that's centimeters squared. Okay, but now the area addition postulate says, hey, if you take those two pieces and you add them together, it'll give you the area of the whole thing. So I get 38.14 square centimeters. Okay, and the idea here is we're just breaking this into pieces that we understand. All right, I don't have a formula for the area of ice cream cone. All right, with including ice cream, it doesn't work that way. But I do know how to find the area of a triangle, and I do know how to find the area of a circle, and I can cut that in half. So we have to find ways to find the area of pieces we understand, and then add those together to find the area of the whole thing. Okay?